Maddie Hall, come on up. Maddie is the co-founder and CEO hi, good to see you, of Living Carbon. I'll let her explain what it is, but it addresses some of the things you've already been hearing about.
Amazing. Well, I know at Living Carbon we use OKRs, so that last presentation was particularly relevant. I'm Maddie, CEO and co-founder of Living Carbon, and we focus on improving the rate of capture and storage in plants using advanced biotechnology. The mission of Living Carbon is to utilize the advanced biotechnology that have allowed humans to develop in isolation from our ecosystem. Really, ever since we domesticated fire, humans have been able to grow our population, but do so in isolation from our ecosystem. And as a result, we've actually degraded 75% of our land. And in addition to that, we've utilized most of our energy that's stored in our natural world. The mission of Living Carbon is to utilize human technology to start to see ourselves as part of our ecosystem and not just here to benefit in isolation from it. Let's see here. If I can get the clicker to work. Oh. Maybe not. There we go. There's our mission. And you can go ahead and see some of our photosynthesis enhanced trees that are 4 months old on the right side of that picture. There we go. Now, Living Carbon focuses on two things. One is carbon capture, and the other is on carbon sequestration and storing that carbon underground for longer. When we talk about carbon capture, that's the first part of that funnel, the speed in which you can capture carbon. And to do that, we focus on allowing trees that would otherwise take centuries and millennia to evolve to be just as efficient as the top 15% of plants that are very efficient at capturing CO2, allowing them to do that in decades and not in millennia or centuries. When we focus on carbon storage, we're looking at how long do plants store that carbon underground. One of the biggest drawbacks of nature-based solutions is the duration in which you can store carbon. How can we use the different minerals that are naturally occurring on our planet and the pollutants and the sites of fossil fuel extraction and turn those into carbon sinks? All of those questions are fundamental to how we think and how we work at Living Carbon. All right, so when I talk about carbon capture, what do I mean? At Living Carbon, we've developed the first ever photosynthesis enhanced tree. And what we released in a paper a few weeks ago is that our trees can capture up to 53% more biomass per acre. These are enhancing the natural properties that occur in different types of plants, like C4 or C3 plants, and allowing trees to be able to more quickly capture carbon over a shorter period of time. We're currently testing these trees in a couple of different pilot projects around the United States. Now, when I was talking about storage, what does that mean? How can you improve the duration in which carbon can be stored underground? A lot of our research focuses on how you can create naturally pressure-treated wood and close to inert biopolymers that will allow us to permanently sequester biological carbon. Now, we do this by accumulating excess metals from the soil and depositing those metals into the lignin of the tree, into the stem and into the roots. Those metals are the same metals that we use to pressure treat our wood, to create this natural pressure treatment process that is actually the same sort of thing that you might have on your deck or other building materials. In this slide, you can see a photo of an abandoned mine land that we're doing some of our pilot planting projects on. This is a site of a former coal company that extracted a lot of the natural resources and left a very lovely hole there. And the soil there, the conditions there, they're not great. And as Living Carbon, we're able to invest in doing the site prep and planting the trees, and then helping those landowners in Appalachia and the Southeast United States be able to take advantage of the carbon markets and participate in the revenue share from those projects. Now, at a high level, what are our goals? At Living Carbon, we don't want land to be the bottleneck to carbon capture. So how can you maximize the amount of carbon captured per acre land over time? Instead of planting 1 trillion trees, what if we take a step back and think at a first principles perspective? How can we improve the speed and durability of the carbon stored by that tree? Right now, we have over 3,000 acres of land that has been committed to do planting projects for living carbon trees, and we're hoping to have 10,000 acres by the end of the year. That will be about 1.4 million trees. And our other goals include increasing the permanence, as I've mentioned earlier, and also showing society what biotechnology can do if oriented around carbon removal. The COVID-19 pandemic is a perfect example of how biotechnology and the advancement in atoms and not just bits can completely transform the speed in which you would typically think about that advancement happening and can completely transform society. We need to show how we can completely reorient our biotechnology industry to focus on carbon removal. If we do that, we can demonstrate how the same technology that has allowed us to extract fossil fuels, to grow our population quickly, to pour cement over naturally occurring bodies of water like the LA River, how that biotechnology can actually help our plant life become more resilient to climate change, and how humans can start to see ourselves as just one organism on a planet and not here in isolation from the rest of our ecosystem. Thank you very much.
Have a seat. So one of the reasons we wanted Maddie to be sort of our first presenter of a startup kind of entrepreneurial mindset is I think it opens up your mind to the range of alternatives we have to take action in the way that Catherine and Ryan have described. So thank you. And also, the way you're thinking about biology, I like, but I want to just, when I heard you, we talked on the phone, my first instinct was, oh, is this scary? I mean, is this going to be uncontrolled, biotech in the wild? But first of all, quickly, why shouldn't I worry about that?
I mean, this is a tricky question. It's one I get asked all the time, this sort of nebulous fear of new things, right? I like to orient the answer to that question around, well, what if you don't research all the possible solutions? What if you don't collect the data on how trees that are enhanced to be more efficient at photosynthesis could actually help the 60% of our plants that actually don't have the animal traffic anymore to have their seeds dispersed, right? You can do so in a way that is how we've studied a lot of new technology, through field trials, soil samples, looking collectively at ecosystem impact, and doing so in a really intentional way that aligns the incentives for landowners, for the companies developing these products, and also is restoring this degraded land where, frankly, not much else is growing at all.
Right, and that's something else that I think is important to reiterate, is that you're not trying to replace natural forests. You're basically trying to grow trees where trees might not otherwise grow, and also make it more efficient and more effective to grow them in places where they can grow if you have the right technology. So I know you worked previously in AI, right? Mm-hmm. And I wanted to raise that because somebody even in the beginning of the day was talking about AI, being an AI scientist in the audience, and it's interesting to hear you talk, having that background. First of all, the role that AI may play in the work you're doing, but in general, as someone who is familiar with that rapidly evolving arena of tech, how do you think of AI's role as a tool in climate action?
It's a great question. You can tell it's been a while since I've been in the software space, given my inability to click on the power.
No, I don't think that was your software inability. No.
I think that there's so much interest in AI, and it's such a gravitational force. And so for me, I actually wanted to step out and see, okay, AI is a buzzword that everyone's talking about. Back in 2019, carbon removal or innovative carbon removal solutions, it wasn't as much of a thing, which is crazy because that was, 3 years ago. But when I think about the role that AI can play, one of the things that I think we still struggle with right now are, how do you model our climate? How do you model the different risks and the different possible effects of integrating some of these new solutions into our ecosystem? That, I think, is a role where I think climate models could get a lot better, and artificial intelligence could play a really large role in helping us proactively think about what the different possible outcomes of these scenarios could look like.
Okay, well, we're pretty much out of time, but one thing I wanted to make sure we reiterated, your trees can't reproduce, right? Is that correct? Or give me that fact as it's correct.
Yeah,
I can tell from your facial expression, it's not quite true. Okay.
I think one really important thing when you're working on innovative approaches to carbon removal is to apply the proper nuance, right? And that's something that's really important to living carbon and to me. So the first species that we're working with, a hybrid poplar, it doesn't produce pollen. If it did, to be honest, I don't think that would be bad necessarily. I think the type of work that we're doing is focusing on improving these natural processes that have existed for millennia. Evolution is a sum of averages over time, and frankly, we've warmed the world so quickly, we don't really have time to wait for evolution to catch up with us. It won't, frankly. Yeah. So I hope that
No, that's a good answer. And we've got to wrap, but often listening to people like you, and I'm so glad you exist, it reminds me of
not everyone thinks that, so thank you.
No, but Stuart Brand wrote a book called Whole Earth Discipline like 12 or 13 years ago, which was basically a very passionate argument that nature doesn't exist. We have to manage the climate and manage our planet. And, so that's the mindset from which you come, and I really appreciate you being here and making a presentation about a very interesting technology.
Well, here's the funny thing. If you take a step back, we actually are nature. We're a part of it. And we can use the benefits that we've developed over time to help nature be more resilient.
Good.
So,
thank you.
Thank you very much.
Thanks so much, Maddie.